Hi again and welcome to Lesson 5 of Android App Development Training Course. Today, you will learn how to use the view binding to easily interact with your views from your XML layout files to your activity file. You will learn how to collect data via the editText and textInputLayout, create and use a string resource, and display information to the user via the Toast and Snackbar messages. You will also learn how to programmatically add views during runtime. At the end of this lesson, you should be able to create a very simple user login activity wherein you can validate the user's input credentials and provide appropriate feedback. I'm going to start by creating an empty activity from the project template and give it a name, text and view binding. In my layout editor, I'll remove this default text view component because you commonly use text view to display an editable text or label to the user. If you want a text view that is editable to the user, such that where your app can accept user input, then you'll have to use a subclass of this text view that has extended functionality, the editText. In the palette window, click Text, and you'll see several text-related controls to choose from. I'll drag a plain text in my layout, as well as a password numeric, and I'll also add another button just below the password numeric. I'll configure this view first by creating constraints on the top, left, and the right of this view to its parent container. This makes this view horizontally aligned in the center. Then the password numeric. I'll create its top constraint to the bottom of the first one, and similarly, I'll create the left and right constraints to the parent. Finally, I'll do the same thing for the button, thus making all these three views to appear center-aligned horizontally. I'll add the top margin to this plain text view so it has a bit of a space from the top edge of the screen. I'll change its width to a fixed value of 300 dp so that it doesn't adjust based from the length of the text that it holds. I'll do the same thing for the numeric password. I'll also change the ID of this that was assigned automatically. I'll make it shorter, edit password, and when I press enter, a rename dialog window appears, suggesting that I should rename this ID resource and its usage for this entire project. So just click refactor. I'll do the same thing for the plain text view and make it edit username. Hit enter and then refactor. I'll do the same thing for the button. Set its ID to button submit, and I'll change the text. Instead of button, I'll say submit. I'll put an 8 dp top margin as well. Now let's run our app first to see how it looks. Well, it looks good. And now notice that when I click on this plain text view, the QWERTY keypad appears, which indicates that I can type any characters here. If you have enabled the use of your physical keyboard input in your AVD manager before, then you can use your physical keyboard to modify the content of this text. But on my end, I'll use my app screen keyboard for you to see what I'm typing. And now, notice the difference on this keyboard layout when I click the password numeric text. It changes to showing you only numeric keypad. And as I type each number, an automatic asterisk hides your numeric password, similar to the ones you see in your phones. Of course, nothing is happening yet when I click this submit button. So, I'll go back to my layout editor and remove this text name that appears by default. And if you want some text that appears to inform the user what this text field is all about, you can use the hint attribute and type here anything descriptive, say username. And notice some sort of a grayed out text appears on this view. I'll do the same thing for the password. Then, I'll select both and search for the attribute align. And what I want to do here is to set its text alignment to center. I'll close this search item and then I'll run the app again. And now I can see the hint and what kind of data I should be providing here. But the moment I type a character, the hint disappears. And this is what this type of view does when you include a hint. It only appears back when you remove the text. I'll leave this issue for now. We'll address that one later. Let's start adding some functionality to this app first. In previous lesson, I've introduced you to the classic way and proven to be dependable means of accessing your views in your activity file. the findViewById function. We've also used a much simpler approach, which is the Kotlin synthetics, but unfortunately, it is already deprecated, and you might ask why. Well, for simple layout, you can still use it, but for a complex app consisting of multiple layouts, there are some known issues that could get you into trouble. For example, with Kotlin synthetics, you can have same view ID in different layouts, and you can accidentally import a view from some other layouts, which could lead to null pointer exception during runtime. Another thing is that if you develop Android apps using Java, then Kotlin synthetics is not supported. It is only useful if you use Kotlin as your language. With that, let me introduce you to the one that supports both Java and Kotlin, a null safety, type safety, and no boilerplate code as well, the view binding. To enable it, go to your build.gradle file in the app module. Inside the Android code block, I'll insert here in line 19, simply type build features, and then set the view binding to true. Just click sync now, and click the make project toolbar. And when you do this, depending on how many layout files you have in your project, the same number of auto-generated Java class files will be created. The binding class file is based on the name of the layout file without the underscore, followed by the word binding. So for example, if we have one file, activity_main.xml, the auto-generated Java class file is activity_main_binding.java. If you want to see where it is placed, change this from Android view to project view. Then, in the app directory, open the build, generated, data binding base class source out, debug, out, com, example, text and view binding, and finally, data binding. Here, we only see one binding class file that directly matches the XML layout file. Let's go ahead and open it. Here, you see a familiar Java class, activity_main_binding, that inherits to view binding. Inside, you'll see the members button submit, edit password, and edit username. And if you scroll down a bit, you'll see that it still uses the findViewById method with additional null checking that you would normally do if you use the findViewById method directly in your code. So, I'll close this one and go back to the Android view, hide it, and open the main activity.kt file. To start using the binding class, I'll declare a private member here that I'm going to name binding, and it is of type activity_main_binding. This is our auto-generated Java class. Inside the onCreate function, before the setContentView function call, I'll initialize this binding variable by calling the activity_main_binding.inflate method, which expects a parameter, layoutInflator. So, this binding variable already holds the reference to the views in our layout file. And in the setContentView function call, instead of us passing the ID r.layout.activity_main, we replace it with a binding.root to refer to this layout. You can also place it in a separate variable like this. And now I'm going to use this view variable to pass it in here. And you're good to go. So to access your views, simply use your binding variable and you can directly access all your views in your layout. But bear in mind, only those that has an ID in your XML layout can be accessed. Those without IDs will not be auto-generated. I'll access the button submit and set up the setOnClickListener. Inside this Lambda function, I'll create two variables that will hold the username and the password of the user when this button is clicked. So I'll use the binding.editUsername.text to get the text attribute and store it to the username variable. I'll do the same with the password. I'll use binding.editPassword.text. So now, just to test whether we can actually get the text from these two views, I'll create an if condition and check if this username variable is equal to a string literal joed. I also want to make sure that the password variable holds a string equal to 1234. And for the app to display a simple message as a feedback on the screen, if both the username and the password match, I'll use the Toast class. Toast is a view that contains a quick and short message for the user of an app, and it automatically disappears after the specified timeout. I'll hit Tab and Android Studio automatically generates a code template for me. It calls on the makeText function, and inside it, we are expected to pass in 3 arguments. First is the context, and I'll simply pass in the current instance this. Second is the text message, so I'll say, "Welcome to Android Kotlin." And the third is the length, how long this toast message is going to be displayed. The default is length_short. You can change this one to length_long if you want. Then, after the text message is generated, I'll call on the show function for it to be displayed on the screen. However, if the above condition fails, then I'll put an else block and display another toast message saying invalid login attempt. And as simple as this, let's run our app to see how it works. I click on the username and type in Joed. Then, in the password, I type 1234. Let me close this numpad first for you to see the toast message. And when I click the submit button, the toast message appears. But unfortunately, the message is not what we expect. It says invalid login attempt, even though we provided the correct username and password, meaning the if condition failed and the else part is executed. The problem lies here in the username and password variables. Since its type declaration is inferred, you must know that it is not of type string, but rather of type editable object. So, I'll convert it first using the toString function, and let's test it again. I'll type Joed, and then 1234, and now I click submit, and there you have it. The toast message says, "Welcome to Android Kotlin." Great! Now let's try to invalidate this login. I'll place joedgo in the username and click submit. And now it says invalid login attempt, and it works very good. I'll try another one, but this time I'll type capital letter J for the username Joed and use the same correct password 1234. I'll click on submit, and an invalid login attempt appears. In Kotlin, when we use the equals function, it is case sensitive by default. And if you want to ignore the case sensitivity, use the overloaded version of this that accepts a second parameter of type Boolean. I'll type true, and this ignores case sensitivity. Let's run and test our app again. Now, when I type Joed in all capital letters and password 1234, the username now becomes valid. Test it one more time. I'll add character C to invalidate it and click submit, and it works great. Now it says invalid attempt. When working with strings and text in your Android application, whether in your Kotlin code or in your XML layout, you'll often see this warning saying hard-coded string should use @string resource. I'll change this to split view, and you'll notice here that some of your codes, like this one, highlighted in yellow, it is not an error, but there is a strong suggestion that we should extract this and use a string resource. I'll scroll a bit, and there's another one. Every time you hard-coded a string, you will receive a warning, and when you hover, you can resolve this one by clicking on this link, Extract String Resource. A dialog window appears with a suggested resource name, usually similar to the actual string value that it holds. I'm good with this name, and I'll simply click OK. And now notice the @string resource prefix followed by the string resource name, submit, is now being used. And if you hover your mouse on it, the actual string value submit is displayed. If you want to go to that specific string resource ID, just press Ctrl key and click on the link. This opens the strings.xml file, and you see here that we only have 2 string resources so far, the app_name and submit. To instantly locate where this file is, open your Project Explorer window and click on this icon that says Select Open File. It goes directly to your res directory, values, and there's your strings.xml together with the colors.xml. So in this file, you can directly add your string resources by first giving it a name, say password_hint. Ideally, the XML naming convention uses underscore for multiple words. And then the actual string value you want to use. I want a hint that says your password. I'll go back to my layout editor, and in the hint attribute, I'll replace this hard-coded value with my string resource, password_hint. And when I hover on it, you'll see the actual string value that will replace this one. It also appears here in your layout design, the hint, your password. I'll go back to the design mode and select this edit username. You can also add a string resource via the attributes window. You can click on this rectangular button right after the value that says pick a resource, and this opens a dialog window for you to select from existing resources. You'll see here the only three that we have so far, app_name, password_hint, and submit. I don't want to use any of this, so to create a new string resource, using this window, simply click this plus icon and choose string value. It opens a similar dialog window that we used before. In the resource name, I'll type user_hint, and the resource value is your username. When I click OK, it is added on the list, and click on OK again to select it. And you see the hint that appears now is your username. Let's run and test our app to see that it still works. I'll start typing Joed, and the hint disappears. Password 1234. Click Submit, and it's good. The correct toast message appears. If you happen to notice in XML code view of this layout, both of these views use the same editText element or view. There are no separate plain text view and password numeric view. All of these are simply editText component that extends over text view component. Its behavior changes simply because of its input type attribute. For this editText username, its input type is set to text person name, and when I click this little flag icon, it gives me a list of all the possible templates that this editText component is capable of. You can try experimenting on it. I'll change to split mode so that you can see that these two use the same editText component. The first one is set to input type of text person name, and the other one is set to number password. You can show the same list of different input types by pressing Ctrl space. I can simply change it to text password. I'll change the other one as well, from text person name to text email address. Let's run our app and see the changes. Notice that when I click this username, editText, the keyboard layout changes to include the @ sign, so I just type joed@gmail.com. In the password field, it is no longer limited to numeric keypad. It can accept any characters, but you still see the asterisk that hides each character as you type. Of course, when I click submit, it will be an invalid login attempt. Although these editText components serve well, but there are several occasions like when you have multiple data entry fields required in your app. There will be times that as you type, you cannot remember what data a certain text field requires for you to enter, and you have to go back or delete the text for you to see the hint again. For some users, this experience is kind of annoying. If you want a view that retains its hint even as you type, then you want to use a different kind of data entry text field component, a textInputLayout. This is some kind of a wrapper to an editText component, but technically, textInputLayout is a view group that extends to the linear layout class. It has one direct child view, which is a textInputEditText, kinda similar to an editText view. I'll drag one in the middle, and then another one. I'll add a top constraint to this second textInputLayout, and the right constraints. You can also do it here in the attributes window. Simply click on this plus icon, and it automatically adds an end to end of parent constraint. I'll do the same thing for the left or start, and it adds start to start of parent constraint. Now, when I click on the above editText view, it seems like that the constraints layout option disappears from the attributes window. You cannot also see the constraints handle here in the actual layout design. The reason is that if you pay attention to what I have mentioned before, this textInputLayout is actually made of two nested components, a view group textInputLayout and a child view textInputEditText. So, the one that we need to select to add a constraint is this textInputLayout. I'll add the end and start constraints. And then, I'm going to change the width of this layout to 300 dp. I'll do the same thing for this second text input layout. Before I add a top constraint to this first text input layout, I need to delete first the top constraints of this button submit and create a new top constraint to the bottom of this second text input layout. Now I can delete these two editText view and then create a top constraints to this first text input layout. I'll add a 32 dp top margin as well. Then I'll select the child text input editText view and change the hint to a string resource user_hint. I'll do the same thing for the other one. I'll use the password_hint. I'll select both the text input editText components and change its text alignment attribute to center. Now you don't see the hints changing its alignment to center because it's part of the layout and not of the text input editText. I'll also add a top margin of 8 dp for this password layout to see these two separately. I'll do the same for this button submit. We cannot run this app yet. Definitely, it will break because our source code is still looking for the previous editText IDs. So, I'm going to set the ID of this first text input editText to edit username, same as the previous one. I'll also change this to edit password. Now, if we take a look at the generated XML tag for this text input layout, you'll notice that it includes a complete package name. Unlike with this button, simply just the component name. This button, as well as the editText views that we used earlier, are part of the core Android SDK. However, this text input layout is a material design component and it is provided by an external library. And if I click on it in the design, you see that the one selected is the child view text input editText. It has different sets of attributes from its parent, text input layout. This is the other text input layout that contains the edit password text input editText. So let's go back to our activity file. But now we have a problem with our activity main binding. Since this one is an auto-generated class, the moment we change our layout components, this class needs to be rebuilt. So I'll click on Build Bundles, and the error goes away. I'll go back to the design, and I want to set the input type of this to number password, and this editText username to text person name. Also, if you want the user to have an option to toggle the password visibility, select the text input layout, look for the password toggle attribute, and set it to true. You should see this visibility icon appears. Now, let's run and test our app. Notice that when I type, the text is displayed center aligned, and the hint didn't go away. It is displayed at the top left corner of the text input layout. Similarly, with the edit password, you can also toggle the password visibility. And when I click submit, our logic still works. Welcome to Android Kotlin. If you see that your binding class is consistently breaking like this, then it means that the binding class failed to auto-generate. You can verify it if you take a look at the data binding directory. So all you have to do is to click the build menu and choose Rebuild Project. This recreates the activity main binding class. Since this binding class file is directly dependent on the XML layout file, it needs to be rebuilt when you modify your layout. Although Toast message is a good means to display information to the user, it has one disadvantage. Toast message is not part of your application, but rather it is part of the Android's notification framework. So it means Toast messages can be suppressed by the user unintentionally if your app is configured to stop receiving notification. I'll add a call to exit process function to exit the app if the user login is invalid. Let's run and test our app. I'll enter some random values and click submit. And now, when the app closes, you can see that the Toast message still persists. This is because Toast messages are managed independently by the operating system. If you don't want this type of behavior, you can use another messaging framework introduced by Google in 2014. It is called the Snackbar message. Snackbar is part of the material design library similar to your floating action button that you've seen once in lesson 1 of this course. I'll comment this toast message and replace it with snackbar. Instead of makeText function, the snackbar uses the make function. The first argument requires a view reference. In Kotlin, when you use the lambda function like this, the reference to this button view is automatically created for you. So, you can simply use the view reference of this button that was clicked using the keyword it. Next is the actual text message, "Welcome to Android Kotlin." I'll insert here the word hi, and then if you want to include value from your variable, you can use this $ symbol. It is used for string interpolation, meaning it is used for variable substitution with its value inside the string. I'll use the username. And the third argument is the duration similar to toast. I'll use snackbar.length_long. Finally, I'll call the show function. Let's run and test our app. I type joed and then 1234, and then when I click submit, the snackbar message saying "Hi Joed, welcome to Android Kotlin" appears. I'll click the submit button again and immediately close the app. And notice the snackbar message goes with it. Another feature that you might be interested when using a snackbar is its capability to display a button as part of the text message. And when the user touches the button, you can write a code that responds to it as well. I'll break this code so you can see everything on the screen. You can create a separate variable to hold a reference of this snackbar message like this. And then you can use it to call the show function. To display a button, I'll use this snack variable and call the setAction function. I can pass in a resource ID or just a simple string like this, show details. The second argument expects an on-click listener interface. So what I have to do is pass in a function of an anonymous object represented by this pair of braces as lambda expression. Inside, I'll call a function that doesn't exist yet. So, I'll use an intention action to create this function, displayToast. Inside it, I just want to display a toast message that says, "Login successful." And what I want to display here is the current system time. I'll use the calendar getInstance method and then time. I'll test and run the app. And then, I'll type joed 1234, and when I click submit, the same snackbar message appears, but this time it has a clickable button, and when I click it, the toast message appears indicating the current system time. I'll clean up my code a bit and refactor these lines of code in a separate function. I'll call validateUser. Notice that it accepts one parameter, it, of type view. It's good, and I'll click OK. So, the instance of this button is passed here using this it parameter. I can now remove this snack variable and then chain this function class together. You can also replace hard-coded messages in your source code with a string resource. But then you might wonder if this is really necessary. Well, the answer is yes. Simply because it prevents duplication of string values in case you want to use it multiple times. Also, it will be very easy for your app to create translation so you can localize it for multiple languages. To do this, I'll copy this string and open my strings.xml. I'll create another string resource named welcome_message and paste in the string value that I copied earlier. Since this local variable will be supplied dynamically later during runtime, you can use a placeholder such as %s for string or %d for numeric. In my activity file, I'll declare a local variable message, and using the getString function, I'll use this second option with multiple parameters and pass in the resource ID of welcome_message. And then the second argument will be the username variable. This will replace the placeholder in our string resource. So I can use this message variable now to replace this hard-coded string. So let's run and test our app. And now when I click the Submit button, the Snackbar message was able to display the same message together with the username. I'll change this toast message duration to length long. Although you can reference your views defined in your XML layout using the classic way of find view by ID or using view binding, there will be occasions when you want that your views are created and displayed dynamically during runtime. To do this in Kotlin, you have to create your views programmatically in an activity and then add it to an existing layout. To demonstrate it, I'll add a vertical linear layout. I want this to appear just below the Submit button. Then I'll create the top constraint of this layout to the bottom of the button Submit. Then I'll add a constraint to the right, left, and bottom of this layout as well. Again, you can also add a constraint using this attribute window. I'll change the layout height so that it only stretches up to the top constraint, which is the bottom of this button Submit. I'll also add an 8 dp margin so that you can see all the edges of your linear layout. I'll be using this linear layout to display the additional view that I'm going to create later programmatically. So I need to set an ID. I'll call it My Layout. Since we've modified our layout file, then we need to rebuild our project to update the auto-generated view binding class. So, to programmatically add a view, I'll create another function here called addTextView. I want it to accept one parameter of type string. Then, I'll create a local variable, say textView1, and create an instance of textView component in this context. I'll set up its text attribute and assign this text parameter passed by the calling program. And then, I want its text size to be 16. And finally, I want its text alignment to be centered. Even though this newly created text view is set up and already part of your app, but it is not yet part of any layout where it can be displayed. So, to display it in your app screen, it must be added to an existing layout container. And I'm going to use this My Layout that we've just created. I'll call its addView function and then simply pass in this textView1 reference variable. So every time I want to create a new text view dynamically during runtime, I'll simply call this addTextView function. To test it, I'll replace the call to this displayToast function and change it to calling this addTextView function instead. Then, I need to pass in a string of login successful and get the current system time. Let's run and test our app. Again, I'll type joed and then 1, 2, 3, 4. Click Submit. And when I click the Show Details button, a text view is added and displayed dynamically. I'll try it one more time. Then click the Show Details, and you can see the second text view is added as well. We can do this continuously and a new text view will be added in effect. So by the way, if you have this kind of lengthy and repeated code, you can always extract it in a separate function. I'll call this one getDate, and this function returns a date. Well, Android Studio is good enough to detect that this code fragment existed twice and offer us to replace both. So I'll click yes, and the two getDate function calls are simply referencing this getDate function. And our app still runs perfectly. As a challenge, try to create a similar app, but this time, I want you to practice your Kotlin programming skills by using an array to include 4 different user logins. If, for example, one of the valid users has a username of Sam, when I click Submit, it shows a snackbar with the message, "Hi Sam, welcome to Android Kotlin," and when I click the Show Details, it shows a toast message of a successful login together with the current system time. If another valid user is entered, for example, Joedgo, same thing will happen. But if the user login is invalid, it dynamically adds a text view saying invalid attempt number 1, including the current system time. The app allows only 3 invalid login attempts. And on the 3rd invalid login attempt, the application will exit, and a toast message will appear saying you have reached a maximum of 3 invalid login attempts. And again, thanks for watching. If you learned something of value here, please click the like and subscribe button for more programming tutorials. This is Joe Edgo and hope to see you in the next video lecture.